Welcome to EMS Mechanical Production. My name is Terry Newberry, and I would like to invite you today to go along with us on a tour of mechanical production facilities to show you what we do and how we do it in the effort to support the EMS overall goals. As you know, we have very unique engineering services within the company, and as a result we have a very unique manufacturing line of products. This actually necessitates a very unique shop. And if you check with the people in here and also on the outside world, you find out that we have an excellent reputation and we take pride in the work that we do. We are very unique from another standpoint, and that is, if you notice the part set before us here, you'll see a very wide variety of geometric shapes that end up affecting the manner in which all the parts are machined. For example, if we take this part with a very thin cross section, which is part of the geometric shape, you'll notice that it's very receptive to vibration and therefore needs certain vibration dampening characteristics applied to it when it's machined. In addition to that, we do several other pieces of the thin wall section. You notice this box, it's made out of a solid blank of aluminum and the walls are 45 thousandths thick, which cause great problems when you're trying to manufacture it with cutting tools. In addition to the thin wall sections, we also have to work to very precise tolerances, always in the 1,000ths to 2,000ths of an inch range, and often in the grinding department down to 200 millionths or 2/10,000ths of an inch. In addition to the tight tolerances, we have very close true position requirements down to 0.0014. Besides that, we also have to maintain extremely close or super good surface finishes. If you'll notice, this is a power divider, and all the surfaces of the mating parts, of which is another half that goes on here, have to be controlled to within single digits to ensure that there's a good interface between the two halves. Any opening caused by an imperfect surface will reduce the performance of the end resulting part. Now that you've seen an overview of the different kinds of parts that we do make here, we'd like to take you on a tour of the various departments to show you the equipment that we perform the work on, and also the advances that we are making technology-wise relative to feeds and speeds and being able to hold the close tolerances to a much more uniform size. Shall we go? Universal milling machine made by Bridgeport Manufacturing in Bridgeport, Connecticut. As you can see, it's very, very flexible, and before the advent of CNC, this is the only equipment that we had to manufacture our complex parts on. The machine being zoomed in on is doing a length of waveguide. It's actually much easier to do it on this machine and bring in the overall length than it is using a very expensive complex machine. Now we can go take a look at those more complex machines. This is one of the first CNC machines that we purchased here around 1985, or one of the last type like this. And you'll notice that it's a 3 horsepower, and you'll notice the feed rate at which it's cutting. It's about 50 to 80 inches a minute maximum. We're face milling the part off, and I'd like you to keep close attention to the rate at which this is moving, and also the other cutters will be moving. I'd like you to compare that to how we do it today, which is 10 years later. We normally have coolant spraying on it to keep the cutter cool and the teeth lubricated, but for purposes of show we have turned the coolant off. You also notice that it doesn't have a tool changer, and that the tools have to be changed manually. In addition to that, there's very little guarding on this machine because they were the first machines that came out. It was very, let's say, not totally receptive to the safety of the individual, which we're very concerned about today. Notice that the new machines are equipped with nut guards not only around the side but also across the top, because we're spraying solid coolant and it tends to atomize when it's the high-speed tool. Again, please notice the feed rate at which the cutter is moving. That's standard for this age machine. Now we'll show you what it looks like on today's flagship of the fleet. Now compare what you just saw on the Series 2 Bridgeport with the Mitsui Seiki, which is our newest piece of equipment and most sophisticated piece of equipment. You'll notice the automatic tool change. This is the face mill speed. The tool change takes about 2 seconds. The machine actually indexes out of the way to ensure there's no damage to the tool by hitting the part. Here again we're talking about 36,000 RPM spindle versus 4,200 on the Bridgeport. We're also looking at a traverse rate of 1,140 inches a minute versus 80 inches a minute on the Series 2 Bridgeport. We've also again left the car door open so that you can see how the machine works. We don't normally work this way. Now we're going into a drill mode, which will show you how fast it can center drill the parts. You'll notice the machine moving in the XY axis and the spindle is in the Z axis. Each one of these has a glass scale on it, so we can hold precise dimensioning. In addition to that, the encoder motors on the ball screws have 1 million pulses per revolution, which is extremely close. It allows the machine to hold plus or minus 40 million tolerance in its positioning mechanism. The machine is equipped with the latest version of the Fanuc CNC control. It's a 16M. It also has an HPPC processor, which is multi-32-bit processors. It allows the machine to read several hundred blocks of information ahead so that it can interpolate the acceleration and deceleration in the contouring process of the end mills. If we don't do this, or doesn't have the ability to do this, what happens is we end up clipping corners and we don't remain synchronous between axis movements to define the shape precisely. In addition to that, you'll notice the meters on the machine tell the operator what spindle RPM it's running, and also the amp meter tells it the draw or the horsepower that the cutter is taking to do the part. You'll notice the numbers passing before you on the screen are the rate at which the control and machine are digesting the information and translating all that binary code into axis movement and tool change. This machine is also equipped with a very nice tool changer external to the working area of the machine. It's mounted on the side and it holds 40 tools. As you can see in indexing, what it does is position the tool in the holder, does a tool change, puts the tool back where it belongs, and takes the next tool to be worked with. So there's no time lost in tool change while the piece is waiting to be worked on. This is another one of our brand new vertical machining centers. It has a table travel of 20 by 40 inches. Notice the tool changer is internal to the machine, not like the machine we just saw. The part being worked on is for Golden Eagle, a phase array antenna. The small M mill doing contouring within the part. This machine is also equipped with glass scales on all three axes, has a 15 horsepower motor. Previously discussed the uniqueness of the kind of parts that we get in the different geometric shapes. And coincidental with that, there's also the quantity of parts that we have to work on. We get orders for 1, 2, 5 pieces. We also get orders for 100 to 200 pieces. In the operating efficiency of a machine, what we have to discuss is, or think about, is the actual spindle turning time. Because if the part isn't being made, we're not making any money. In order to cope with these new set of circumstances, we have invested in a Sagami flexible machining system. It's a horizontal machining center equipped with 10-station pallet changer along with 62 tools. With these unique features, we can now run the machine on the third shift lights out operation on parts that have reasonable volume. The left end of the machining system houses the carousel that holds the 10 different pallets that are on the machine at any one time. It also has the operator loading and unloading station where on this particular fixture we have 16 J-Stars housings ready to machine on 3 faces. When the operator has loaded or unloaded the parts and then loaded fresh parts, he will then activate the system which will load this pallet into the carousel. From this station we can also program the next pallet due in for machining in any sequence we want. You'll notice that there's a number on the end of the pallet here. This number is designated by binary code to a pickup here that sends a signal up to the control to tell it that number 7 pallet is in the slot to be machined next. That will tell the control will tell the machine which program to select and which tools to use to machine the parts on that particular pallet. To viewing, we have removed the Lexan safety panel that normally covers this position here. What we're going to show you is what happens when an M60 code is punched into the program and the calls up for a pallet change, so we can take the work that's completed out of the machine and put the new pallet in the machine. You notice the door moves vertically, both pallets are drawn into the center, does a 180 index, pushes them back out, the door closes, and we're ready to rock and roll. That takes a total of approximately 8 to 9 seconds. That's all the lost time we have
between working cycles of parts within the machine. In the next compartment, we have the actual machining area where the spindle is located. We have the Z-axis, which we've slowed down here to show you in a horizontal rather than a vertical position. And we have the X, which is the up and down, and the Y-axis of the pallet over here, again, which we've slowed down so you can see. It's traveling the limits of its travel. In addition to moving up and down, it also has the ability to index in 1 degree increments. Now, if you watch closely, the tool changer arm is up here, and we're going to show you the fastest tool change in the shop, 1 second. If you were watching, you saw it. If you weren't, you didn't see it. The carousel on this machine is mounted in a horizontal position in a duplex situation with 32 tools on each tool. So when a tool change is made and the tool is put back in the location it came from, you'll notice that the carousel rotates, picks up the tool in a proper pocket, brings it down and puts it back in the right location, so that it knows at all times where each tool is. For everyone to have a little better appreciation of what's actually involved in the manufacturing of some of the different parts we get here in mechanical production, we thought we'd give you an example here. This happens to be the Millstar electronics enclosure. We start off with a billet of 6061 T6 aluminum. It's 5 inches thick, 14.5 inches long, and 12 inches deep. First thing we do is to gut out the center of the box to remove as much material as possible. What people don't realize is this is actually alive. This stuff is loaded with stresses when it's made. All aluminum product is, unless it's cast or brought down to a T0 temper. So what we do is we hog it out and then we stress relieve it at 600 degrees Fahrenheit for approximately 18 hours to try to bring it back to a dormant or less stressed state, so that when we work on it and bring it into the finished product, we don't have so many problems in holding flatness, parallelism, and concentricity, and all those requirements that are placed on the drawing. If you look at the part, you'll notice that there's extreme amount of work done on this part. In fact, it takes over 118 man-hours to produce this from a solid piece. In addition to that, it takes 13 NC programs and 7,884 feet of information input into the CNC machine to make the part, and then an additional 8 hours to deburr the part to acceptable levels. So by knowing all these facts, it's very easy to understand that it's not a simple put the piece in the machine, but very involved in making the part to come out with the finished product that we need to EMS standards. One of the most important but least recognized departments within mechanical production is the deburring department. It doesn't use any $100,000 or $200,000 or $300,000 machining centers, but it does take a lot of patience and a lot of expertise in order to do the finishing operations on sometimes very expensive parts. The part can be either made or broken in this area, and we certainly appreciate the efforts that they put into making those parts good. We also want to take this opportunity to show you a little bit of the QA department. Although we're separated because of formalities and the way it has to be in business, you can't have QA reporting to manufacturer, manufacturing reporting to QA. We are a very close network team. All of our parts must be inspected for first article and also as a finished part dimension and the lot size. So we have to work very closely with QA to get this work achieved and made correctly. What we have here is an illustration of a coordinate measuring machine with a CNC controller. You'll notice that the Renishear probe has been programmed to go in and measure with 3 blips in each hole. It gives a true position and size of each hole based on a program that was input through the CNC controller. For the most part, most of our patterns with a large number of holes or a large configuration on it are done on this particular machine. We have a small one. And bringing our completed tour to a close here, we'd like to show you briefly our plating department and our new facilities off NX 660. To your right, what you just passed, is the iridite line for both bleach and gold iriditing. To the left, we have tin plating, zinc plating, electroless nickel, gold, and silver plating. You notice that covers are on most of the bins because it's after closing time, and they're all caustic baths, so they need to be protected from somebody putting their hand in them unwantonly. So in close, a view of our painting facilities where we do all the priming and finish painting of the finished parts as we get them ready and prepare them for shipment. Well, we want to thank you very much for accompanying us on this tour, and we hope that you are more well informed of actually what goes on in mechanical production, You've only seen a small portion of it, and for those who are interested in learning more, we welcome their visit and would give them any information that they'd like to know about. Thank you and have a good day.